All right, so let's cover our compound inequalities. So we started with our normal inequalities. Equations give us one answer. Inequalities give us a range of answers. Now we're combining inequalities together. That's where we get the compound from. We're using the words and or with different inequalities and looking at how that changes the solution set. We're going to start with the and. That's what an intersection is. Okay? Intersection is where they meet, where the inequalities overlap. Okay? So we're looking for a set of solutions that satisfy both inequalities. Okay? It has to be true for both inequalities. So we identify what the solution set is for each one, and then we find out where they overlap. Okay? You'll see the word and. You'll also see the intersection symbol here. Okay? That's the intersection symbol. It's like a little arch. Okay? Intersection means and. We want to find where they overlap. Before we look at inequalities, let's look at just two sets. Okay, we have set A and set B. Set A is all values of x such that x is an odd number greater than 0 but less than 9. So what are some odd numbers that are greater than 0 but less than 9? 3, 5,
7, 1.
and 1. Okay, so this is set A, right? Are these numbers. And then set B is these numbers. So the intersection of set A and B is what numbers are in both sets. 5 and 7. 5 and 7 are in both sets. So our intersection is 5 and 7. Okay? Where they overlap. Right? Question. So let's go ahead and look at an inequality now and see how that adjusts it. Because remember, an inequality is now a range of numbers. So those sets had finite terms in the set. They had finite values. Now we're dealing with inequalities that have a range of numbers. So we solve our inequalities separately. I have x plus 4 is greater than 0, and 4x is greater than 0. We solve them each independently. I get x is greater than negative 4, and I get x is greater than 0. Okay? So we're going to graph both of those, and we're going to look and see where they overlap. And that is the solution to our inequality. Okay? So I've got my first one. Let's look at x is greater than negative 4. Here's negative 4. Okay? Open circle. And which way am I going to shade? To the right. Next one. X is greater than 0. Here's 0. Open circle. Also shades to the right. So where do they start to overlap? Earlier than that. At 0. The overlap starts at 0. Okay? So the solution set is still there. That's where the overlap is. Okay? Starts at 0. So the graph of my solution set is x is greater than 0. That's the inequality for my solution set. X is greater than 0 because that's where the overlap starts. My interval notation, 0 to infinity. Okay? So for the compound inequality with the intersection, this is my inequality. This is my interval. And this is my graph. Okay? And make sure you pay attention to what the question is asking for. If it wants the interval, the inequality, or if it wants the graph, maybe it wants a combination of those. You need to know what each different one is. Okay? Intersection, where they meet, where they overlap. Questions on that? This is just one type of solution you'll get, where one of our inequalities is the answer for the intersection. Okay? It happens a lot. one of the inequalities will be the answer for the intersection. But we'll end up with some that are a little bit different. So what I want you to do first, you're going to do two inequalities. I want you to solve and graph both of them independently, and then we'll do the intersection together. Okay? You can think about what the intersection would be, but graph each of them independently. Okay? Solve them both and graph them on their own number line. And then we'll look at what the intersection would be. Graph them both. Right here. Right here. So you don't have to do it in your head. Graph them both. Okay, so we get 0. Now open circle on the 0 and closed on the 3, I believe. Yeah, okay. So open circle on the x is greater than 0, and then we got x is less than or equal to 3. Where's the overlap? They do not ever overlap. They're going in opposite directions, and there's a gap in the middle. And I need any numbers that would make both of these inequalities true. And there are none. There is no number that would make both of these inequalities true.
Why the first inequality is 0?
Why is the first one 0? Okay, so when we look at our number line, all right, there's 0, there's -3, okay? There's no overlap. Actually, that should be blank because that's our solution. We need to leave our solution blank. There's 0, there's -3. They're going opposite directions. There's no point where they overlap, okay? So it's no solution. All right. We also have a symbol that you're going to see. That's not a 0. Not a 0. That's an empty set. Okay? Circle the line through it means empty set. There is no number that satisfies this compound inequality. Therefore, our set is empty. We have no solution. And the number line stays blank. Because there's nothing on there. Okay? So sometimes we'll get that with compound inequalities. We'll get one of our inequalities a solution, or we might get no solution. Okay? One of our inequalities is a solution, or no solution. Those are some of the most common ones. Okay? Now, we'll also have this as our third type. Okay? Again, we're looking for overlap. So, solving a compound inequality in 3 parts. Our process is the same. So let's ignore this less than 9 for a minute. Okay? We'll come back to it. But let's ignore it for now. What would be my first step in solving for x? With 3 is less than 5 minus x. What would I do first? 3 is less than 5 minus x.
Oh, add 5.
Yeah. Okay? So my first step is to subtract 5. All right? And then I'm going to be left with negative x. And if I have negative 2 is less than negative x, not negative 2, what's my coefficient here?
Positive. Oh.
Okay? So subtract 5, divide by negative 1, right? Those are the two steps I would use to get x by itself on this inequality. We're going to do those same two steps, but with all 3 parts of the inequality. Okay? Subtract 5 to get it out of the middle, but I'm also going to subtract 5 on the left and the right. Okay? All 3 parts. Negative 2 is less than negative x is less than 4. Second step was divide by negative 1 to get it out of the middle. I'm going to divide by negative 1, divide by negative 1, 2, negative 4. What do I have to do with my inequality symbols? Gotta switch them. Why am I switching? Because I divided by negative. So switch that, switch that. So now I have 2 is greater than x, which is greater than negative 4. So I have my critical values, negative 4 and 2. What circles am I going to use on my critical values? Open for both of them, because neither of them have the or equal to. All right, so let's look at this left one right here. I've got x is less than 2. Which way would I shade from the 2? Left. Okay, so, and then x is greater than negative 4. Which way would I shade?
Right.
Where is the overlap? In the middle. There's my solution. There's the graph of my solution. All of them 2. What would my interval notation be for all the numbers between negative 4 and 2? What's my interval? Nope, I got to start at my critical value. What's the lowest value? Negative 4. How do I say negative 4 is not included? What symbol do I use next to it? Not a trick question, ladies and gentlemen. So the circle is on the graph, but what about in the interval notation? Is this means the same thing? Do we need to go back to those symbols? Look in your notes from yesterday. Look at the symbols on our interval notation. This worries me because pretty much all of your answers for your homework are going to be in interval notation. And so you don't even know how to put the answer. The union is going to be used in some of this?
No.
This?
Yes.
Nope, not using that. Nope, that's an intersection. That's not interval notation. If I had x is greater than 4, how would I write that in interval notation? What interval tells me 4 and all of the numbers bigger? Parentheses. Okay, that's my interval notation for x is greater than 4. When I ask for interval notation, you need to know exactly what I'm talking about. Because we have inequalities, interval notation, and graphs. And when I give you an assessment, your test on Tuesday, and I ask for interval notation, or I ask for an inequality, If you don't know what that means, I cannot tell you on your test day. You need to know what those vocabulary terms mean. You need to know what the answer should look like when I give you those directions. So when I ask for the interval notation, I'm not putting it up here for my health. I'm showing you all the different ways that the answer could be asked for. This is our graph, or I'm sorry, this is our inequality. This is our graph. Now I want the interval. So again, I'm trying to represent all numbers from -4 to 2. Parentheses. Okay, -4 to what? 2. And then what am I going to close it with? What am I going to close it with? Another parentheses. Okay? When do I use brackets? Don't come into my class and have another conversation. When do I use brackets instead of parentheses? Ooh, this is concerning, y'all. It was weird because you had a homework assignment that did this.
When equal them, right?
When you have the or equal to. Maybe I should assign extra practice problems. Just to make sure you guys have it. Interval notation, inequality, graph. When I ask for one, you need to be able to know which one I'm asking for. Inequality, interval notation, or a graph. Now, those were our intersections. Union. Okay? Intersection is answers that satisfy both inequalities. It has to meet both of them. So when you think about an intersection of a road, where they meet, a union just needs to satisfy one of them. So it's all of the numbers that satisfy one or the other. Think of a union like a marriage. You get married. You take all of your stuff. You take all of your spouse together. Okay? Because sharing is caring. All right? So when you bring all of your stuff together, all right, if you had something that they don't, well, now they have it because you have it. All right? So a union is as long as it's in either of the sets, it is a solution for the whole inequality. Okay? And we use the union symbol, which coincidentally looks like a U. Makes it easier to remember. Okay? Union, U, together. Okay? Or. Keyword is or. So here we're looking at another union, same set that we had in the beginning. So my odd numbers, 1, I don't know why I did 3 or 5 first. 3, 5, and 7. Okay? So that's set A, and then set B is 4, 5, 6, 7, 8. So the union is all of the numbers. So what's the smallest number that's in either set? 1. What's the next smallest number in either set? Next. 4. Then. Notice I did not write the 5 or the 7 twice. You only ever need it once, okay? It doesn't matter if it's in both sets. This is just asking, hey, what number is in both of these sets? Well, 1, 3, 4, 5, 6, 7, 8. Those are all of the numbers that exist in those sets. I don't need to duplicate if it shows up in both of them. It only needs to be written once. That's our union. Okay? Solve these two separately, graph them, and then we'll do the union together. Close the app and reopen it, and you should be able to join it back in. You won't have to put the code in. That was a little lackluster there. Always simplify fractions. If it is a repeating decimal, you need to leave it as a fraction. Okay? Always leave it as a fraction, even if it's a repeating decimal. And so I've got 8/3 and 6. Now, in order to graph this, I need to know what is 8/3. 8/3 approximately is what? I'm going to graph 6. Okay, 2.6, 2.7, between 2 and 3, right? So there's 2, there's 3. All right. So for x is less than or equal to 8/3. What kind of circle am I going to use on my graph? Why closed? Or equal to. The or equal to. And then which way am I going to shade? To the left. Less than or equal to. All right. X is greater than or equal to 6. Closed circle. Shaded which way? Okay. So now, when we had an and, when we had the intersection, this was no solution because there was no overlap. But I don't need an overlap with or. It's any number that satisfies either one. Okay? So our graph, that's 2, that's 6. Our graph will be just both of these together. All of those numbers and all of those numbers together in a union. Wonderful. All of those numbers and all the other ones on the right. Now we need to look at the interval. Okay, so my inequality is this. Okay, that's my inequality. So if it asks for an inequality, x is less than or equal to 8/3, or x is greater than or equal to 6. If it asks for a graph, here's our graph. Graph each of the inequalities on the same line. There's my graph. Now I need an interval. So what's my interval for the left side of my graph? What's my interval notation? That set. Lower than that.
2.
Lower than that.
0.
Lower than that. Lower than that. What's the lowest possible number that can be a solution to that left inequality? Keep going. Negative infinity. Keep going forever, right? That's what that arrow means.
But there's a negative.
Negative infinity. Negative is that way. Positive is that way. Okay? So negative infinity. Now, I'm going to go all the way up until what point? Nope, there's a gap. So where did it stop here? At 8/3. So negative infinity all the way up to 8/3. Infinity always gets parentheses. What's the 8/3 going to get? Parentheses or bracket? Bracket. Now, the one on the right. Where does it start? Starts at 6. And it goes to what? Positive infinity. Okay, again with the parentheses and the bracket. So it's both of those. And it's a union. They're together. So we have to say that they're together. That's when we use that symbol. For the union. That's when we use that symbol. We have the left side of our inequality. We have the right side of our inequality. There's a gap in the middle that is not included in my answer set. So I need to indicate that there's a gap. That's what that union is. I take all of these numbers on the left, and I take all of these numbers on the right, and I bring it all together. Bring it all together. Okay? Interval notation, graph, and inequality. The only time you will use that union is when you have a graph, it's an OR equation, and there's a gap in the middle. It's the only time you're going to use that union. Otherwise, you don't need to use it. Because everything else overlaps or is connected. It's only when we have that gap on an OR. Okay? Go ahead and solve and graph these on the same number line. You may want to use different colors for each line, but solve and graph them on the same number line. Forgot to flip. This is good. You got to flip your inequality on the -2. Divide by -2, you got to reverse the inequality. Okay? So it's -2, greater than -2, less than 0. So, when we look at this, -2x. Wow, that's really off. Let's try that again. Okay. Divide by that -2. Reverse that inequality symbol. That's the biggest thing you have to remember. If you have that negative coefficient, you need to make a little note. Flip inequality. Okay? You gotta do something to remember to flip it. So I have x is greater than -2. So here's all of those. X is less than 0. It's all of those. So the union is everything together. So looking at those two lines, what numbers are not in my solution set? Is one not? Yeah, one's greater than -2, so 1 works. Give me a number that's not. Huh? 11's greater than -2. It works. It's all of them. Because it's combined together. So any number that's not in my greater than -2 is included in my less than 0. So because I had that overlap, and it's an OR inequality, my solution is all real numbers. My number line is everything. All real numbers. All real numbers. What's the interval notation for all real numbers? -infinity to infinity. So it's all real numbers. -infinity to infinity. Okay? Questions, comments? You'll start to see patterns. They'll repeat. You'll see specific intersection and union problems. Specific intersection problems have kind of the same reoccurring answers over and over and over. Okay? They're similar in how they're set up. Same with the union. The types of answers you get are very similar. Okay? So the more you practice it, the more you'll see those similarities. Okay?